Hello everyone, my name is Arya Deodhar and this is part 1 of NCERT Class 10 Science, Chapter 1 Chemical Reactions and Equations. Okay, so this chapter, Chemical Reactions and Equations, is the foundation of chemistry for boards. So please pay attention and make sure that you get a good grasp on this chapter so that you can get going with the rest of the chapters. Okay, so in this video, I'm going to be explaining two main concepts. The first one is the representation of elements. This is not given in your NCERT, but I think it is fundamental for you to know and revise that how can we write down elements, right? So it is representation of elements using symbols. So you might be familiar with most of the elements, but some of them might be new to you. So you have to remember the symbols in order to write down their chemical reactions. Okay, so the first 20 elements of the periodic table plus some other important elements which might be repeated throughout this chapter. And the second part is about what exactly is a chemical reaction, okay, and how can we recognize a chemical reaction. So, and its recognition. So there are 5 ways in which we can recognize a chemical reaction. So we are going to talk about that. Anyways, let's start with the first one, which is representation of elements using their symbols. So I have written down the first 20 elements to save time and I will be writing down their symbols. Okay, so hydrogen is H, helium is He, lithium is Li, beryllium is Be, boron is B, carbon is C, nitrogen is N, oxygen is O, fluorine is F, neon is Ne, sodium is Na, magnesium is Mg, aluminium is Al, silicon is Si, phosphorus is P, sulfur is S, chlorine is Cl, argon is Ar, potassium is K, and calcium is Ca. Okay, and there are a few more. I just remembered one more, which is iodine. Okay, so anyways, let's write down these as well. So we have zinc, which is Zn, lead, which is Pb, iron, which is Fe, copper, which is Cu, silver, which is Ag, gold is Au, barium is Ba, tin is Sb, and iodine is I. Okay, so these are some of the other elements besides the first 20, which are also important. Okay, so make sure that you memorize these. Most of these you must be familiar with. The rest of them just learn. Okay, so let's move on. The second part is what exactly is a chemical reaction. So I'll give you 3 points which you have to remember and understand in order to write down the definition of a chemical reaction. So the 3 points are, the first one is a chemical change, okay, a chemical change. The second one is formation of new product or products of new, okay, and last one, which is given in NCERT, is the breaking and making of bonds. It rhymes. Breaking and making of bonds. Okay. So the proper definition of chemical reaction is not given in the NCERT textbook, but if you remember these 3 points, you will be able to write a sufficiently viable definition. Okay, so the first point is chemical change. So you might have studied about chemical change in your 8th and 9th standards. Okay, chemical change basically refers to when a new product has been formed. Okay, a chemical change has taken place. So that is when a chemical reaction takes place. Okay, second point is formation of new products. Whenever reactants react or substances react to form a new product or products, then a chemical reaction has taken place. And the third one is breaking and making of bonds. So in a chemical reaction, basically what happens is that the reactants, they have some atoms, right? They have their atoms in a particular structure. Now, when some catalyst or some, heat or something is applied, or basically when the chemical reaction takes place, the atoms rearrange themselves, in a different structure, and they form a new substance, which is known as the product. So, bonds between the atoms, there are bonds. So, bonds are broken and then they are remade, or they are made again to form new products. So, breaking and making of bonds. Okay, so I hope you understood the 3 points. I'll give you an example. Okay, so the example here is very easy. 2 mg plus O2 gives 2 mgO plus heat plus light. Okay, delta sign, this is delta, it is used to denote heat. Okay, here magnesium reacts in the presence of oxygen, or burns, and magnesium burns in the presence of oxygen to form magnesium oxide along with the release of heat and light. This is the word form of it. Okay, so here this side, left hand side of the arrow, they are known as the reactants, and here on the right hand side, these are known as the products. Okay, so reactants react to give products, and the arrow in between, it indicates the chemical reaction. It indicates that a chemical reaction has taken place, which indicates the reaction. Okay, and whatever I have written here using the symbols, using the plus signs and the arrows and everything, that is known as a chemical equation. We'll be talking more about that in the next part. Okay, so I hope you understood this reactants, products, and what exactly is a chemical reaction. Now, moving on, recognition of a chemical reaction. Okay, so there are 5 ways in which you can recognize that a chemical reaction has taken place. Now, what are those ways? The first one is formation of precipitate. Formation of precipitate. Now, here precipitate is basically a solid. Okay, it is a solid product which is formed or obtained. Okay, it is a solid product. So the reactants react to form this product, right? And which is obtained, right? It is obtained, it is formed, whatever. Okay, it is a solid product obtained. Simple definition. Example, let's take an example of PbNO3 whole bracket twice plus 2Ki gives PbI2 plus 2KNO3. Okay, so this is a good example. So here the states are aqueous, this is precipitate, and this is also aqueous. Okay, so the thing which is magical or fascinating here is that both these solutions, they are colorless, they do not have any color. Okay, but when they are mixed together, immediately a yellow color is formed. Instantaneously a yellow color is formed, and this is due to the formation of PbI2, that is lead iodide. So in the word form, this can be said as lead nitrate reacts with potassium iodide to give lead iodide and potassium nitrate or nitric acid. Simple. Okay, so this is the example of formation of precipitate. Okay, now next we have a change in color. This is a quite obvious one. Okay, so if you notice carefully in this reaction as well, the change in color can be seen from colorless to yellow. Okay, so that indicates a chemical reaction has taken place. I'll still give you another example. See, when SO2 gas, that is sulfur dioxide gas, is passed over potassium dichromate solution, K2Cr2O7 solution, okay, then this solution, it changes. The color of this solution initially is orange. Okay, it is an orange colored solution. It changes to green after sulfur dioxide gas is passed. Okay, so that is, a magical thing to see. It is very instantaneous. Okay, SO2 gas is passed over potassium dichromate solution. Then we can see the change in color, which indicates that a chemical reaction has taken place. Okay, moving on. The third one is evolution of gas. Evolution of gas. Okay, so what this means, it means that after a chemical reaction has taken place, some gas gets liberated or evolved out of whatever beaker or test tube in which you are doing the reaction. Okay, for example, let's take an example. We have HCl plus NaHCO3, sodium hydrogen carbonate, gives NaCl plus CO2 plus H2. So here this is aqueous, this is aqueous, this is solid, gas and liquid. Okay, now here you can see this arrow which I have drawn, right? So what does this arrow indicate? It indicates that the carbon dioxide gas has been liberated. Okay, now you know that carbon dioxide is a colorless and an odorless gas. You cannot see it, you cannot smell it. Then how will you know that it has been liberated? So there are some tests. Okay, so there is a test for carbon dioxide and hydrogen, which I'm going to be writing down here. Okay, test to detect that it has evolved or it has liberated. Okay, to prove that a chemical reaction has taken place, basic thing. Okay, so here for CO2 the test is passing through lime water. Sorry, passing through lime water. Lime water is a solution of calcium hydroxide. Okay, passing through CaOH twice, which is lime water. Okay, turns milky. So when CO2 is passed through lime water, it turns milky, and this milkiness is due to the presence of another compound. Okay, I am not discuss it here, but it is due to another compound, and that indicates that it was CO2 gas which has passed through. Okay, so that detects CO2 gas. And the second test, which is for H2, that is hydrogen, is a burning matchstick. So you have to hold a burning matchstick close enough so that the hydrogen can pass over it, and you will see that the matchstick, it burns with a pop sound. So that sound, okay, so it's a very funny sound, but that is how you detect the presence of H2 gas. Okay, these are very characteristic things for both of the gases, as they are both odorless and colorless, so you cannot detect in any other way other than doing some chemical reaction there. Okay, now moving on to the fourth way, which is change in temperature. Change in temperature. Okay, so either whatever, for example, if you're doing the reaction in test tube, the test tube either becomes hot or it becomes cold. Okay, two ways in which you can determine a chemical reaction has taken place. Example, let's take an example for both. Okay, for the first one, CaO plus H2O gives, sorry, CaOH twice plus heat. Okay, so here the test tube, it becomes hot. The test tube becomes hot because heat is released. Because heat is released into the atmosphere. Okay, so this reaction releases heat, and hence the test tube becomes hot. It becomes warm. Okay, so you can see the heat released here. Simple. Okay, the second example is interesting. It is a very unique example. It is also given in your textbook. Just make sure you notice it is given in some activity, I think so. So BaOH twice plus NH4Cl gives NH4OH plus BaCl2. Okay, in this reaction, the test tube, it becomes cold. It becomes cold because for the reaction to take place, it absorbs heat from the atmosphere. Okay, the test tube becomes cold because heat is absorbed. Because heat is absorbed. Okay, clear? So here barium hydroxide reacts with ammonium chloride to give ammonium hydroxide and barium chloride. Simple. Here, the test tube becomes cold because the heat is absorbed from the surrounding. Okay. Now, the last one, the last way is change in state. Change in state. So what is this? You know that the states are solid, liquid, and gas. The common state. There is plasma and stuff like that, but that is not necessary here. Solid, liquid, gas. Okay. Example. I'll give you an example. See, burning of wax. When wax is burnt, I'm not saying melting. I'm saying burning. Burning of wax is a chemical reaction. It is a chemical change, and in this reaction, how do we recognize that a chemical reaction has taken place? Well, the solid, it changes to liquid, doesn't it? Right? So a chemical reaction has taken place, but this change in state, it is not always necessary that a chemical reaction has taken place, because if you, for example, see a controversial example, I would say contradicting example, ice turns to water. Ice turns to water. So this is not a chemical reaction. It is not a chemical change, it is a physical change because it can be interchanged. Okay, so it's this way as well, it's this way as well, right? Reversible reaction, which is not a chemical reaction. So ice turns to water is not a chemical reaction. So it is controversial. It is, so this change in state you will not see in many cases, but it is there. It exists. So you have to study it. Okay. So the best example to remember is burning of wax, solid to liquid. Okay. So that's all for this lecture. Uh, I hope you understood everything. It was the starting part is pretty simple. Okay. So that's it for today. Thank you so much.